Great. Well, I'm going to get started. I think we're getting the last trickle of the hallway line coming in. My name is Stephen Elliott. I'm a senior product manager on Amazon EC2. And this is obviously the introduction to Amazon EC2 presentation. Thanks for your patience. I think we had some trouble with scanners and the sheaths for your badges. But just to get a show of hands, how many of you have never touched Amazon EC2 before? OK. It's about half. How many of you have maybe worked with it, let's say, less than a week, kind of poked around, prodded? And how many of you would consider yourselves experts, but you want to see if I'm going to lay down a bombshell during this presentation? Those are like 3 of you. OK, great. This really is going to be an introduction, a primer. I'm going to say some things that maybe a lot of you already know and frame Amazon EC2. So just to give you a sense for what to expect. Here is what we'll cover. First, I'll introduce what Amazon EC2 is and kind of go through the history of the service and how much it's evolved since we launched it. And then kind of define some fundamental concepts about Amazon EC2 and the value that it delivers. And then we'll get into some companion services and customer case studies. And I'll even do a very quick demo at the end to show you how easy it is to launch and get the number of hands raised for people who haven't touched it at all way down. So what is Amazon EC2? So to start with, EC2 is an acronym. It stands for Elastic Compute Cloud, which you could shorten to ECC. And for some reason, EC2 felt better. So it's Amazon EC2, even though EC2 is not shorter than ECC. We've been around for 7 years. We're 7 years young. And when we started, we were a very focused service. We had one single instance family in size. It's the M1 Small, with one virtual core, 1.7 gigabytes of RAM, 160 gigabytes of storage, and we only ran Linux. And in addition to that, we had on-demand pricing. We had no management console. We didn't have elastic block storage, no elastic IPs, no virtual private cloud, auto-scaling, or elastic load balancing. We really started as a very focused compute service. And over the last 7 years, we've just grown really, really fast and iterated extremely quickly on features that customers have asked us for. So you probably got a sense of this from listening to Andy's keynote this morning. But one of the biggest ways in which we've innovated in Amazon EC2 is with the instance type, so with the virtual servers that you run your applications on. So now we have a large number of instance families covering many different use cases, from general purpose to compute optimized, which I'll get into a little bit later. We have many different operating system offerings, Windows, Enterprise Linux, made a lot of improvements to the AWS management console, so you can manage everything through a graphic user interface and launch things pretty much within minutes just by logging in. And we've done some other things just to make the elastic compute experience much more seamless. We have elastic block store for persistent storage, elastic IP addresses, a virtual private cloud, so you can logically isolate parts of your network in the cloud and have it interact seamlessly with your on-premises data center. Programmatic auto-scaling, so you can scale horizontally across your virtual servers depending on the load that your application is seeing. Elastic load balancing to point load to the auto-scaled instances. And really countless improvements to performance, security, and manageability, basically the bread and butter of managing a first-class application in the cloud. Just to get a sense of the scale and the global presence, you saw the similar slide during the keynote, but we are available globally in 10 different regions, Beijing being the most recent one that we announced, and 25 different availability zones or data centers within those regions, with 51 edge connections, so for the content delivery network of CloudFront. So it's really important to keep in mind that everything that I discuss with respect to instances and how instances behave, put it in a global context and think about the future of your company and what it means to be able to scale globally, whether it's into Ireland or Australia or South America or China. It's a really powerful concept. So what is Amazon EC2? I've already said that it's virtual servers that you run your application on in the cloud. These are resizable compute instances, and we offer many different instance hardware profiles and sizes within those hardware profiles. And the really important thing is you can provision one or basically as many as you want. You don't have to choose in advance how many you want to run. And as you're running them, you can choose to scale up further or shut them down depending on your application's needs. Along with that is the important concept that you only need to pay for what you use. We offered various different pricing models, but fundamentally, cloud computing is the on-demand delivery of IT resources via the internet, and you only need to pay for what you use in the pricing model. And that's what Amazon EC2 provides. And furthermore, we don't lock you into any particular operating system or development environment. If you like to run Windows, you can spin up a Windows instance. If you like to run Linux, you can run the Amazon flavor of Linux. You can run Red Hat, SUSE, CentOS. Really, you can choose the environment that you want to work on and run that in your instance. So here's kind of a text map of the families of the Amazon EC2 instances that we offer. And what we found is that many customers have different use cases, and we need different hardware profiles for those customers. So we started with the general purpose instance with the M1 small, but we added memory optimized instances for applications that need large, for example, in-memory databases for in-memory analytics, genome assembly, compute optimized instances for batch processing, Monte Carlo physics simulations, all kinds of applications that require a lot of compute power. Micro instances for example, low traffic web servers. We find a lot of customers do testing on the micro instances before they decide to vertically scale into a larger instance. We have our free trial, a free tier on the micro instances, so you can run them for free. Storage optimized instances, where your application might require a lot of input-output operations per second, or a massive disk space. And so we offer, for example, I'll get to this on the next slide, an HS1, which gives you 48 terabytes of disk. Or GPU instances. If you're a game developer and you want to stream games to your customers, or you want to do rendering, or even simulations for your chemistry analyses. So within each family, we have these different hardware generations. And we started with the M1, and M3 is now the most recent generation. In the compute-optimized family, we started with C1 and CC2, and now C3 are the most recent generations, and so on for the other families. So what's really important there is we are constantly introducing new hardware types to keep up with the leading edge of hardware. So you don't have to stick with the old hardware that you're running on. You could stop that instance and spin up an M3 to get all the benefits of the new M3 instance, or stop your C1 instance and spin up on C3 to get all the benefits of the C3 instance. And really what these represent is different CPU, memory, disk profiles, and networking profiles for each instance type. But to give you further control, we also slice those up. So you might launch on an M3 M3 medium, and the next week or the next month you realize that you need to vertically scale. And rather than running 2 M3 mediums, you could decide to switch over and start running an M3 large. And so we give you control over how much of that hardware model you want to run. And those are our instance types. And medium, large, what you see here are the instance sizes within each hardware generation. So here's some recent instance highlights, and to give you a sense of kind of all the different flavors of instance types we have with some numbers behind them. We have the Hi1, HI1 high input-output instance type with 120,000 read IOPS and SSDs, solid-state disks. And the most recent generation of that we launched was I2. So that has 350,000 random reads and IOPS per second. M3 is the most recent generation of our general purpose instance. And HS1, like I mentioned, is a really beefy instance if you want to run your Hadoop application or a really heavy-duty data warehouse on it. HS1 is a really great choice with 48 terabytes of storage. CR1 is a high memory instance with cluster networking support with 244 gigabytes of RAM and a Sandy Bridge Intel processor. The G2 that I mentioned, that's an NVIDIA Kepler GPU. And the C3 is the most recent generation of the compute-intensive instance type with a 2.8 gigahertz Ivy Bridge core. And with the option of running with solid-state disks if you need that ephemeral storage with the instance. So on the storage point, we offer locally attached instance storage. And the type and the amount differs by instance. And we also have Amazon Elastic Block Store standard volumes and Amazon Elastic Block Store provisioned IOPS volumes. So standard volumes will give you kind of a normal performance of of IOPS performance for kind of stable or sometimes peaking workloads. But if you need an application that requires a constantly high IOPS level, you can ask for a provisioned IOPS volume and get up to 4,000 instead of the usual 100. And what's really nice about these is they don't have to be tied to a single instance. So you might spin up a virtual server, and it boots off the root volume that was your Elastic Block Store, and you decide that you want to vertically scale and go to a larger instance size. You don't have to recreate everything from scratch. You can stop the instance, save your Elastic Block Store for the next instance, reattach it, and spin up on a new virtual server. So that's what's really nice about Elastic Block Storage. So who uses EC2? I think it's helpful to go through some customer examples of people in enterprise and research spaces who are able to make very effective use out of EC2. The first customer example is Dow Jones. As you know, they deliver business information to investors all over the world. And like many companies, they had to face this question of how to serve their global customers better, and were thinking about replacing their Asian data center. And they were looking for a cost-effective way to do that. And if you ever procured a data center, or thought about it, you know, this is not a thing that you look forward to. Especially if you're operating in another country, you have to figure out new partnerships, you have to identify what hardware you want to buy, and the amount that you buy has to be sufficient to cover your projected peak usage, which you might not even know about yet because it's a new market. And that takes a lot of mind share, not just from the team that you've assigned to setting up the data center, but from, you know, the product managers, the finance, the executives. And so instead of doing the legacy way of expanding globally, Dow Jones decided to go with AWS and found that they could save $40,000 on hardware and also get to the market almost a third faster, 30% faster. And so Stephen Orban, the CIO of Dow Jones, says, thanks to AWS, we now build more products and spend less time running a data center. So that part's kind of subtle, but it's very important in that not only are they saving on their hardware costs and their capital expenses and their operating expenses in their Asian data center, they're also able to spend less of their development time on running it and more of their development time on the core value, on delivering that business information and the business information products to their customers. So here's another example of kind of a similar case with Expedia. And I'm sure everyone knows what Expedia does in this room, but they're one of the world's leading online travel websites with many different imprints around the world. And they have a growing customer base in Asia, and they were thinking about how to serve their Asian customers better. And so there's actually a really interesting service in Expedia. They found that whenever you kind of run into an error when you're searching for your itinerary, that's one of the major reasons why someone will leave Expedia and go to another site. So how do you reduce the number of errors that a user encounters on the site? So they came up with something called Expedia Suggest Service, where if you type in Seattle because you want to fly to Seattle, it would autofill as you're typing, doing a type-ahead recommendation of what city it thinks you're talking about. And before, all of their operations were run out of Chandler, Arizona, and they saw that latency for certain customers in Asia and around the world was 700 milliseconds. And so they were doing a great job at improving the customer experience, but you still had to kind of wait almost a second, 700 milliseconds for the recommendation to start popping up. And to improve that customer experience, they really want to build a compute presence in Asia. And instead of going the traditional way, they decided to do it with AWS. Now, this case is particularly phenomenal because they were able to do that in 3 months. So they were able to build out their Expedia Suggest service in Asia in 3 months, improve their CPU utilization by 230%, and now their director of technology says that they run several critical applications in AWS because they can scale and use the infrastructure efficiently. So whatever solution they've come up with in Asia, they can now take that, lift it, and put it in Europe, or they can put it in South America. And that's really the power of having this EC2 model of development available globally. And 3 months, by the way, since I'm a product manager, 3 months is a pretty amazing time to talk about setting up a data center replacement, because some of my products that require setting up no capital expenses, no operations, take way longer than 3 months. So we're talking about an entire new feature that in the old world would have required an entire data center. Now it took them only 3 months. I'm going to go through some of the key benefits, and these are kind of the takeaway messages from this talk, if you will. Amazon Elastic Compute Cloud, one of the key benefits is that it's elastic. Hopefully you remember that. That you can completely control the resources that you provision. It's flexible. We focus on reliability. That's been one of our primary focuses from the beginning. It's secure, and it's inexpensive. So I'll kind of go through all of these and give you examples and help you understand why customers are able to get all these benefits from Amazon EC2. So first, on the elasticity point. We're going to kind of go back to basics, but one of the big goals here is to simplify your operations and scale only as required. We want to get out of the model of scaling in advance, buying expensive, making expensive capital expenditures and buying expensive hardware way in advance based on potentially faulty projections, and just kind of following your demand curve with as tight an envelope of virtual servers as possible. So that's, the orange line is kind of the envelope of cloud instances that is meeting the demand, that's the blue line. And at the same time, you want to improve resiliency. So whether that means you're locating your instances in different geographic locations so that they're isolated and independently operating and there's no single point of failure, you want to be able to do that. You want to be able to run them securely, take advantage of the best practices in data center security, application security, network security. Run any application, so you don't want to be locked into a particular development environment or an operating system, and at the same time reduce your costs. So I'll talk you through just kind of, this is a hypothetical example, but let's say you have a website and it sees a lot of traffic around noon. Maybe this is Mealster or some other company that just recently launched, and maybe they get a lot of orders during the day. And after some time running their application, they realize that around noon they require 4 units of compute, and during the rest of the day it kind of tapers up into 4 units or tapers off at 4 units. So just kind of using basic geometry, you see that they're only really using whatever servers they would launch for half of the day. And the other half of the day they don't need their peak capacity. So what would this look like on Amazon EC2? Let's say that one server on Amazon EC2, one instance on Amazon EC2 could satisfy 2 units of capacity here, 2 server load units. And the traditional capacity required in the old world of buying capacity would be to buy the 4 units all in advance, to buy these 2 instances all in advance. And in fact, you might even buy 3, because you're not actually sure that you're going to peak at 4. You might peak at 5. You might peak at 6. So you're going to overbuy. But just for the comparison, let's say you buy exactly where you peak. In the EC2 world, you spin up one server when you need to start meeting some demand for 8 hours. And then around noon, you'll leave that server running, but you realize that it's starting to, either its CPU is starting to peak, or there's another metric that you're following with CloudWatch that's showing that you really should get serve more connections with another instance. So you launch another server. And then when that peak is done, you might wait a little bit just to make sure that you haven't seen a fake decline in demand. But then you'll shut it down. And so just off the bat, just by following that model of on-demand consumption and on-demand pay-as-you-go for instances, you're able to save 1/3 off of if you had just bought and ran everything up front. And you can see how this becomes really just this simple template and this simple model of thinking about it can save a lot of money for other situations as well. So here's a peaking situation where it might just be a couple days at the end of the month. It might be your bill run or your log analytics or something to do with payroll. And you always know it's going to happen at the end of the month, and it's typically taken 6 instances. And so because you know how your application performs and you know when you don't need capacity and when you do, rather than buying 6 in an on-premises data center, just run 1 instance for 25 days of the month, and then run the 6 instances for the 4 days at the trailing end of the month, and then come back down. And if you do something like that, in this case, it would save you 75%. What's really powerful about this, too, is you don't need to know when that peak's going to happen. This peak could, maybe you have a load where you're actually doing social media analytics, or you're doing something else where you're not actually sure when you're going to require the 6 units of capacity. And you don't even know if it's going to be 6 or 7. The ability to scale up on demand really leads to enormous savings and efficiencies. So completely controlled. What does completely controlled mean? You have complete control of your instances. When you spin up a server, you can log in, SSH into it, install updates, change the software that's installed. And if you like what you have and you want to launch more instances with that kind of package, you could create an Amazon machine image out of it and attach that Amazon machine image to new instances that you spin up. So you have complete control over the environment. You can make any configuration changes you like and start or stop it as you like. And when I do the demo at the end, I'll show you just how easy it is. So here's what it would look like if you spun up a Windows instance or a Linux instance. It's exactly the experience you would see. You log into your Linux instance and just start entering the command line commands that you want to run your application. Or if you are completely automated, the startup script takes care of everything, and you're on your way. Flexible. So I've talked about a lot of the key aspects of flexibility in Amazon EC2. You can choose an instance type that suits you, and you're flexible to experiment. You can start with T1 micro, make sure that your AMI is working, your Amazon machine image is working, and then try it in M1 small, see if that's the right size. Maybe you need more CPU power, try a C1, C1 medium, or a C3. Maybe you need more memory, try an M2. And you can change that instance type when you want to because you have persistent storage on your Elastic Block Store, and you can just stop it and then start up a new instance type with the same block store. And then you can actually change the amount of storage that you need. So when you spin up an instance and you're using Elastic Block Store as your root, you can say, I want 8 gigabytes to go with that, or I want 16 gigabytes. And so we offer you that flexibility as well. And as I mentioned before, you can choose your operating system, and you can configure your AMI. So reliability is another really important aspect of Amazon EC2. This is something that we've been focusing on for a long time. AWS itself was founded because Amazon had over 10 years of experience running highly reliable, scalable systems, and continued to invest in that area while offering the product to developers and businesses. And so it's really easy to build highly available and reliable architectures because that's how Amazon EC2 was designed. In addition, we just have several features that make it very easy. So having multiple geographic locations within each region, multiple availability zones that behave in the same way allows you to just put your resources in different geographical locations for reliability and resilience. We have kind of companion services, elastic load balancers, and auto-scaling will help you automatically redirect load for your application to different instances that might be in different geographic locations. So here's an architecture of kind of a basic 3-tier web architecture. You have your customer at the bottom who's accessing the content delivery network, might be getting some content streamed from Amazon Simple Storage Service. But when that customer is interacting with the service, an Elastic Load Balancer first determines which web server is going to serve that customer, and that can auto-scale. So maybe you only have one customer at the beginning of the day and you have one instance running. But once you hit 100 customers, the auto-scaling will automatically spin up a new instance, and Elastic Load Balancer will start balancing the load. And on the back end, you may have application servers that also are connected to the web service through an Elastic Load Balancer. And if there's a database instance, you may have a master in one availability zone and just have your replicas in other availability zones, so you also don't suffer from a single point of failure on the database side. So this is it's a very powerful pattern, but that's how Amazon EC2 allows you to build highly reliable applications. So security. I think really security is one of the tenets of Amazon Web Services and Amazon EC2. We take the best practices of the industry, and whenever we have to do anything extra in terms of security, whether it's one of these certifications, FISMA, ISO 27001, SOC reporting, the improvements we make to benefit the security of one customer just automatically benefit all customers. So we're constantly improving the state of our security, and it started from great, and it's continuing to improve. And the important thing to note here is if you're in a particular industry, like you're in the healthcare industry, you don't have to do this research on your own. So we have HIPAA certifications. If you are handling payment information, we have PCI certification for payment card information. So we're always iterating and moving forward on the security certifications and security features that we have in the cloud. Another part of security is things that you may want to control yourself. So you can use Amazon VPC, Virtual Private Cloud, to logically separate and even isolate parts of your Amazon EC2 cloud. So you can provision a logically isolated section and then control parameters of that section. So you can control the subnets, the IP address ranges, the routing tables, the security groups, and you can do that all from the AWS Management Console, and all very easily. And so you might decide that part of one subnet should be externally facing and deal with traffic, but another part should be much more secure, not be connected to the internet at all, and internally facing. And you can do all of that with virtual private cloud. And if you're in the process of migrating or thinking about migrating to the cloud, you can set up an Amazon virtual private cloud and then a hardware VPN connect to the Amazon cloud from your on-premises data center so that it all behaves seamlessly as one data center, even though half of it is on Amazon EC2 and half of it is on-premises. So that's another really important part of VPC and the security offering is it's secure even in the migration process where you're operating both environments. So here's an architecture diagram of what that might look like. You have, at the bottom, your on-premises data center, your own employees working on it, and then a VPN connection to the Amazon EC2 VPC. And the VPC spans 2 zones. That's the availability zone 1A, availability zone 1B. And then you can just set up the subnets where you want them to be. You might set up 2 subnets in availability zone 1A, one subnet in the other, and you can control the IP address ranges and where to launch each instance. You can choose exactly which subnet you want to launch instances. So you really have a lot of control. And then maybe one of those subnets talks to the internet. And then inexpensive. You know, obviously this is in Amazon's DNA to always pass on as much of our cost reductions onto customers in the form of price cuts. But before I get to that, what's also really unique about Amazon EC2 is the different pricing models we offer. So there's kind of the quintessential cloud computing pricing model, which is on demand, which you provision and shut down Amazon EC2 instances on demand, and you only pay for what you use. So we start from 2 cents per hour with Linux Unix instances, and this can work for almost every application. But if you decide that after monitoring your application, you realize that you always run a certain amount of load, and you want to save money on your usage for that application, and you may want a capacity reservation to make sure that instances are available for you to spin up when your application needs them, you can invest in reserved instances. And reserved instances, we offer 2 different terms, 1 or 3 year, and various utilization types. So you can kind of determine for yourself how much you want to spend up front to secure yourself a capacity reservation and an ongoing hourly discount. And part of this also is volume tiers. So the more you use AWS and the more you use reserved instances, the more of a price cut we can pass on to you as a customer. And these can be quite substantial. So with heavy utilization RIs, these are instances you probably expect will be running 80% of the time, give or take. You can get up to 58% savings off of the on-demand price. So this is something that would be great for databases, large-scale high-performance computing, just whether or not it's a stable load or something that peaks that cycles very frequently for high utilization. Heavy utilization RIs are a great choice. Medium utilization RIs also can give you great savings. Here, you might not expect the instance to be on over 80% of the time, but maybe it's on between 40 and 80% of the time. And so we can pass on savings to you. You don't have to pay as much upfront. The hourly discount isn't as steep as the heavy RI, but you still get a substantial hourly discount off of the on-demand price. And if you expect less utilization than that, we have light RIs as well. So another thing we do with reserved instances is maybe you started off in US East 1, that's a region, and you start off in availability zone 1A in US East 1, in our Virginia region. And you bought your reserved instance to secure capacity reservation in 1A, and as you run your application, you realize that a lot of your environment's in 1B, and you actually would like to have your reserved instance, your reservation in 1B. So we allowed you to modify the reservation, and literally with a click of a button, if you're changing the parameter US East 1A to US East 1B, behind the scenes, we are actually reserving an instance for you in a completely different geographic location. And that's something that you can do through the console or programmatically via the API. If you do a large purchase at once, if you buy, let's say, 4 M1 smalls as reserved instances and you decide that you want to vertically scale, remember that we're talking about M1 small as a size of a type of instance hardware we're providing you. And another size in the M1 family is M1 large. So we give you the option of collapsing the 4 M1 smalls to be 1 M1 large in case your needs change as you are evolving on AWS. So here's a graph. I'll just kind of explain it a little bit and then talk to you about why it's cool. So on the left is the total amount you would expect to spend on the instance over the life of the instance. So if it's a 3-year reservation, this is the total amount of money you would spend on that reservation over those 3 years. And then on the x-axis is your expected utilization for that instance. So how much you expect to be using that kind of hardware. Remember, it doesn't have to be the same instance. You could run one instance, shut it down, and as the next instance that you run has the exact same parameters. That counts toward the utilization of the reserved instance. So the simple world is the gray line. It's the one that starts at the origin at $0 and just goes up. And the slope of that is just the on-demand hourly rate. But if you decide you want to pay a little more and buy a light utilization reserved instance, you pay a little bit upfront. So the y-axis intercept, it's a little bit higher, but you get a lower hourly rate. And so at a certain point, it's cheaper than running on demand. If you expect your utilization to be even higher than that, you could buy a medium. And then heavy, you might ask, why is heavy a flat line? Because heavy operates is expected to benefit customers who have 80% or more utilization rather than having slight unpredictability of how much your monthly bill will be. We just say, pay up front for a heavy, and you essentially have the same monthly cost month over month. We charge you for every hour in that heavy instance. But even though we charge you for every hour for utilization of greater than 80%, it's better than a medium reserved instance, and it's much better than an on-demand instance. So you can kind of trace the line that you want to be on. This is the white line, and just decide which RI suits your application's needs. So what does that allow you to do? So we go back to the example where you have an application that peaks and has a load that's really high around noon, but it's not as high in the morning, it's not as high in the evening. So how would you apply the flexibility of our pricing models to that kind of application? Well, there might be some minimum baseline load that you always need to satisfy for customer experience and responding to connections. So you might decide that the first 2 units are always heavy utilization RIs because they're on all the time. The next 4 units going up to the 6th line might be medium utilization RIs because those really are only on about 50% of the time, 50, 60% of the time. So it doesn't make sense to buy a heavy, but it does make sense to buy a medium. The light utilization RIs are bought for the instance usage that you expect to be on maybe less than 40%, but greater than 15%. And then what's really important to note here is that means because you have these reservations, we are reserving capacity for you so that you will be able to meet 10 units of demand. But if you're off with your projections, you can still run on-demand instances. And so that top tier above 10 units is on-demand instances. We're charging you the on-demand rate. But the really nice thing is you haven't made a commitment. You have the flexibility to run those or turn them off when you want. And everything above heavy utilization is the same way. You only get charged the hourly rate for what you use. And then finally, we have a model called spot instances. One of the ways in which we deliver lower price to customers is we try to maximize the utilization of our compute fleet. And spot instances is the product that sells our spare EC2 instances, so the instances that weren't sold via on-demand and weren't sold via reserved instances, and sells them to customers. And there's a key trade-off here, but it's an extremely powerful trade-off. The trade-off is you tell us how much you're willing to pay per hour. It might be 70% off of the on-demand price. And we let you run the instance as long as no one else is willing to pay more. So you might get kicked off, but think about all the applications where that makes a lot of sense. Let's say you're encoding a bunch of movie files or audio files or PDFs, and those jobs take on the order of minutes. Well, with Spot, you might have millions of those things, and you don't really care when they get done, but as long as they can get done at less than, let's say, 0.5 cents per core hour, you're willing to run them on Spot. So you get to run them at a significant discount, and you get to spin up way more Spot instances than you can spin up otherwise. So a couple cool customers that use Spot in really effective ways to lower their compute costs are Tapjoy. So Tapjoy does help support mobile applications with ad analytics and ad serving. And they actually have, not only do they do continuous integration on Spot, because when you think about continuous integration, it's OK if the integration test fails if you just do it later, depending on how you set up your development environment. They also have something called Tap in the Box, where on a web console that they've developed, they just press a button and spin up an entire production scale environment of their product on Spot instances. The worst case scenario, that production environment gets shut down because someone's willing to pay more. But the best case scenario is they spend 80% less than they would otherwise, and they have a test at scale of how their environment performs. And over the last year, so they learned about Spot at reInvent in 2012, and between reInvent 2012 and reInvent 2013, they saved $500,000 just by figuring out what it means to do opportunistic computing. So Spot's really powerful that way. So one of the big things that we have been doing recently is these products were launched in January, is just helping you see how you can save more money. We have instance usage reports and reserved instance utilization reports just to show you how effective your reserved instances are at saving you money. Or if you've made a wrong choice, if you need to sell it on the reserved instance marketplace or modify it to be in the availability zone where it'll save you more money. And you can just access all of that in the management console. So here's a case where you can see your reserved instance performance. The text might be a little small, but in this case, the customer has an M1 large. It's in EU West 1A, and it's been saving, even though it's only been utilized 27% of the time, it's been saving the customer $648 over this month of it looks like December to January. And then you can see how your instance usage breaks down over time as well through the usage reports. So another key tenet of this is if we're going to tell you that you can spin up instances on demand and we only pay for what you use, it should be easy to do that. So I'll just walk you through. Once you've set up an account, which only takes a couple minutes, just go to the EC2 dashboard and request to launch an instance. So I'll just show you how to do that really quickly. So here's the EC2 dashboard. If you logged in, this would be the Amazon Web Services Management Console. If you log in, this is the first thing you're going to see. And you can walk over to, move your mouse over to EC2 and click on it. And now you're at the Amazon EC2 dashboard. And we'll give you some summary of what you have running. Right now I have a running instance. I have one Elastic Block Store volume, 2 key pairs, 20 security groups. Get a little tip about RDS. And right in the middle, I could launch an instance right there. But let me just see what I have running right now. So I click on instances. And it looks like, so I have 2 instances that I've stopped. And like I said, that means that I'm not getting charged for it. I'm only getting charged for the EBS storage, which is a very small charge. And I have a persistent block store that I can spin up later if I want to. So one of these is actually a demo app that I have that does a movie based on a fractal rendering. And I don't need that to be running all the time, but when I want to run it, I can just press start on the application and it starts going and rendering JPEGs into simple storage service. And this T1 micro instance is running right now. But I might decide that I want another one running, so you can go to launch instance. And here's where we give you a lot of flexibility. You might just want to explore and just log into the instance and see what you can do and launch Amazon Linux. As you can see, there's a whole bunch of other quick start options, Red Hat, SUSE, Ubuntu. If you have customized your machine image and saved it so you can launch the exact same thing later on another instance, you could look in your My AMIs section. I don't have any right now, but you would see all the custom AMIs that you've made. This is a really powerful option, which I'll talk about later, is the AWS Marketplace. So you might not want to set up and have to configure your entire server to do something that someone else has already done. And so in the AWS Marketplace, you can find over 1,300 listings of environments that vendors and other people have set up for you that may not even cost money. A lot of these are free. In the last customer example I'll give you, they don't have a surcharge at all. And just start spinning up an application to do work for you. Here's some more community AMIs. So I'll just start simple. Spin up a Linux instance. Here are the families: general purpose, memory, storage, micro. So micro is free tier eligible. I'll go with that, even though I'm an internal account and I don't get charged money. So next, configure instance details. So you could just decide to launch just like this and log in. You might have instance details that you really want to set. Here you could decide I want it to be a spot instance. So rather than spending the 2 cents per hour, it looks like current spot prices are 0.3 cents per hour. I might decide I want to bid 0.4 cents, but I'll just leave it as a normal on demand. I like the storage option that it gives me. I don't have to do that. Maybe I want to tag this with my first name. And you can kind of go with that. Get a summary, launch it. You have a private key. and now it's launching. So you go back to the instances dashboard, it'll tell you that it's pending, it's spinning up. We're initializing it right now. You could even look in and see the logs and see what's going on. But the end state will be it'll look like this. And so it'll take a couple minutes, but just to fast forward a little bit. Once it's running, you can just connect to figure out how to connect to it. And I use PuTTY for this case, so I'll just copy this. This has my username and then the DNS for the computer. So I'll just copy that. And PuTTY already has my private key, so I don't need to re-enter that. And then just open it. So now, so it says it's using username EC2 user, and it should log me in just as if you were logging into a server, when you're in your data center or in your lab, and start doing whatever you need to do. So it looks like there's some 17 packages I need for security. So I can start controlling it exactly as the super user. So maybe I want to do an update. It'll give me all the packages that I can update. That sounds great. That's just a really simple example. Obviously, there were no bells and whistles on that demo, but you really can go from deciding you just want to test something out to testing it within minutes. We can switch back to the presentation. So you saw the AWS Marketplace in action. We have 1,300 offerings, over 1,300 offerings in it. And it's an online software store. So we have partners, ISVs, and other partners that sell solutions via the AWS Marketplace. Individual customers might decide to sell solutions that way as well. And you can just find environments that you want to spin up on an instance and run them. And so it's a one-click launch. What we do in the AWS Marketplace is tell you, here's how much it'll cost to run the instance that you want to launch, and here's any surcharge, if any, that the vendor wants to charge you. The powerful thing about this is that it's a one-click launch. You don't need to do anything different. You don't need to buy the software somewhere else and make sure that it's available. It's kind of been vetted and tested, and it's secure, so you know it's going to spin up when you launch it. And then you just use your AWS account to purchase it. So while it appears separately as software and AWS service charges, it's in one place, and it supports invoice billing. So there's no mysterious pricing, and everything's very clear about how you're being charged for what you're running off of the AWS Marketplace. And then, like the other important part about Amazon EC2, you can scale up and down as you want. So it charges you based on the instance hours that you use the product, but you're not paying a massive upfront license fee that gets wasted if you don't utilize the thing 100% of the time. So here's an example of a company that made great use of the AWS Marketplace, not a company, university. So a researcher at University of Liège was doing Parkinson's disease research. And what usually takes 2 weeks, in this case took 2 days for the researcher. They were looking for a new kind of neuroinformatic solution for the research they were doing. And it turns out that the new NITRC, Neuroinformatic Technology and Resource Center, has a compute environment in the AWS Marketplace that they charge $0 for. So the only charge is the instance usage, where the researcher can just spin it up and start using the different neuroinformatic tools for his research. So Eric Ziegler at University of Liège said that finding NITRC on AWS allowed him to complete a critical stage of research in 2 days instead of 2 weeks. This is another really, really important part about Amazon EC2, which is if you only think about the costs, you're actually missing sometimes the most important part of scalability and on-demand usage, and that's saving people time and focusing your important talent on the problems that matter. So in the case of Expedia and Dow Jones, the quotes we're talking about is focusing on products that matter. In terms of research, it's focusing on the problems that matter. So Parkinson's research, you have a highly trained researcher at the University of Liège, and the last thing that researcher wants to be involved in is operating his own data center, writing the grants to install that computer capacity, and then working through the licensing and installing it. My view on this is that we just have so much value in people's brains, and there's only so much you can think about in the course of the day. The less you can think about the infrastructure and the more you can think about the problem that matters. It's really powerful, and it makes a really big difference in science. So the cycle time here, in one month, if your cycle time is now 2 days, in 1 month you can get 15 iterations done. and in the previous world, it was 2. So that's kind of where I'll draw the presentation to a close. I encourage you to try it for the half of you that never touched it before. You can sign up for an AWS account and just spin up a T1 Micro on the free tier and just play around with it. You can learn more just by going to our website, awsdiamondon.com/EC2. I'll be available after the presentation for questions, and you can also join us in the booth to ask any technical questions you have, pricing questions, et cetera. But thank you very much, and enjoy the rest of your day.